have your take-home problem, the problem ready, the graded homework. Yeah. Number can anybody do the number 3? About the geometric distribution? Yeah. You want to use the definition of, you want to conditional probability here. Let me use a whiteboard. We want to show that p of x, given that x is greater than or equal to a, equal to a plus c of x for a geometric distribution. So we want to define the conditional random variable. Remember the probability of x, given that x is greater than or equal to a, is equal to probability of x divided by probability of x greater than or equal to a. Where now this x is greater than or equal to a. So we are defining a new random variable y, which is x. So we have a new random variable, x greater than or equal to a. So the mean of x, given that x is greater than or equal to a, is equal to the sum from a to infinity x of p of x divided by p of x greater than or equal to a. Now I'll ask you a question which you should find out. You should try, you should know this one from your note. What is x greater than or equal to a? Remember when we finish towards the end of the geometric distribution, we find this when we were computing, we were trying to look for the memoryless property of the geometric distribution. Where you can find it? This is f of yeah, this is 1 minus x greater than or equals to, let's put it this way. X greater than or equals to a. What do you have in your note? 1 minus f of x is less than a, p alone. So this is, I don't want us to spend the time doing this. This is x greater than a minus 1, which is 1 minus p of x is equal to a minus 1. And we got this one last time. Can you find it in your notes? You guys should do it for geometric distribution. So like it's much easier for me to do it. know, right? You make it. Anybody has that? You don't write what you are doing on the board. We were solving a problem here. You write all the problems we solve. Any of you? I can check when you are solving. This is the problem. That's what I'm asking you to do. Look, we are looking for x greater than or equal to a, which is b of x greater than a minus 1. So you have a. You can change it to a minus 1. You have it? Okay. So this is x greater than or equal to a. Yeah. So this is p of x greater than or equal to a that you have here. 1 minus q x equal to a minus 1. I don't want to do that again. That's why I'm looking. And at the same time, I want to make sure. Have you found it? But even if you miss that, it is one of the graded homework problems. It's on one of the graded homework problems. So you have p of x greater than or equal to a. So can we use it? It is what? Maggie, do you have that? 1 minus q to the what? This is p of x greater than a plus 1. Where is the a plus 1? So what is p of x greater than or equal to a? I thought I saw it in both of them. Let me check one. Okay, let me just do it again. What is p of x greater than or equal to a? We say this is the same as p of x greater than a minus 1, which is 1 minus P of x less than or equal to a minus 1. But we want to know what is f of a in general, or what is f of x? Is the sum from 0 to x of u a. Do you understand what I mean here? Is p of x less than or equal to x. Here you should make the difference between the big and the small x. That's why sometimes I use a, which is p of 0, p of 1, p of x. That is what I'm writing here as 0, x. P of anything is the probability of success, the first success, and the number of failure is x. Which we say was p of 0 to x, u raised to power k. If we wrote as p times, starting from 0, we have 1 minus q x plus 1 over 1 minus. For this sum, the 1 minus q is p. So that's why we have 1 minus q x plus 1. So this is f of x less than or equal to 8. Your problem was a little different in what we were doing there, because you have greater than here. So I am changing it now. You have greater than, not greater than or equal to. So you are not going to get exactly the same answer here. But when you are doing this, f of x less than or equal to a equals to that, a plus 1 here. Then p of x greater than or equal to a will be 1 minus q what? qa. It would have been a minus 1 plus 1. So this is what gives you qa. This is p of x greater than or equals to a. What if you are doing a Montmorillon's problem which is greater than, it is x greater than a is x greater than or equals to a plus 1. Because it's 0, 1, 2, 3, 4, 5. Could you continue if you know this one? P of x greater than or equals to a. So we have p of x divided by p of x greater than or equals to a. What is p of x? Q x times p divided by qa. And what is this equal to? Remember, our x here each are greater than or equals to a. So this is equal to q x minus a times p. This is that probability distribution we had. Do we get what I'm writing? So I can continue here because I want it to remain on the video. So p of x greater than or equal to a, we say was equal to qa. So we are going to come back here and write that this is equal to that P of x, given that x is greater than or equal to A, is equals to P times Qx over Qa, which is P times Q x minus A. So we are doing here number 3. Remember that, so that we don't get confused with. So we have P of x is equals to the sum of x, P, Q, x minus A to infinity, which is equal to A times what? Starting with A, what is the first term? The first term here when x equals to A. Pardon? Okay, you should know that this was P of x greater than or equal to A. I didn't write it completely. It's x, given x greater than or equal to A. That's why we are starting at A. So it will be A times what? Plus A plus 1, okay, P, Q, A plus 1 minus A. You understand what I'm saying here? X is A plus 1. Q, A plus 1 minus A. Plus what? A plus 2 times P, Q square. We can complete this one, right? So which is equal to AP plus APQ plus APQ square . Is that right? We will have, I am doing the first A first. I'm doing A. Then plus what? Plus PQ plus 2PQ plus KPQ K. Can we say this? Pardon? Yes. Good. Right? We just follow our steps. I myself will not know how, I do not think how you are going to do it, but that is just the step that lead to what. So now you can observe here that this is A times sum of P, Q, K from 0 to infinity. The first part, the first AP plus APQ plus APQ square, we can write it like this. The second, we can write it like X, P, Q, X from 0 to infinity. right? You will see the solution and you complete it from here. Pay attention to what is here. What is PQK? Pardon? Okay, that is what you want to see. This is the sum of all the probability. Geometric distribution is PQX. The sum of the geometric distribution will give you 1. Let me say that I didn't complete it, that you will complete this one. So just write it again neatly. You can submit it later or on Wednesday. Put it in my door if you finish after this. If I'm not there, just put it under my door. But go back, what you were writing, you saw some of the, correct all of those ones. So make an effort as you are solving some of these problems to think to yourself, does it make sense? Is what I'm writing making sense? That's my objective. It is not just to grade that at the end you did it all well, you get the 5 words. Any other question? Pardon? Number 5. Has anyone done number 5? You want to show us so that we work it together? It doesn't really matter. Even when you get it wrong, there's nothing wrong about it. It's more difficult for me to look at this than when we are solving it. Is E of X equals to this? Okay. You see, I don't even know what E of X is. Yeah, and you know it's a geometric distribution, and you know what the mean is, right? And you find the standard deviation, and you determine, yeah, you can trust what you are doing. Like, yeah. So you find the mean and the standard deviation, and you decide to get values that are within 2 standard deviation. Good. At that point, we can explain for everybody to complete. Do we understand what she's doing here? So you want to find that probability, knowing that the geometric values are 0, 1, 2, 3. So you want to know what are the values that are there. Let me check again if you completed it well. That's where you stop. You need to find this probability. And what will be the probability actually? Can you tell? What are the values of x? X is a geometric distribution. If x is greater than or equal to -3 and less than or equal to 7, what are the values of x? Can you get -2 as the value of x? Jacob, what are the values of x? If x is greater than -2, what are the values? -3, what are the values of x? Anthony, pardon? She gets to this point. What are the values of x? Because she did not complete. Can x be -3? Why? No. That's not the reason, yeah. Why won't you know why won't you know why? What is x? Yes. You want to have -2 success? All right. I want us to understand what we are doing. So yes. What about 0? We have been working here with 0 to, right? That is the purpose of this work. That's why I give you just few problems. I want us for those few problems to learn things that we may not realize as we are working. So the random variable of the geometric distribution is 0 to, your probability is from 0 to 7. I want to give you another hard. X is between 0 and 7. What does it mean? X is greater than or equal to 0 and less than or equal to 7. Is that right? Can we say it is just x is less than or equal to 7? So what you have is to find p of x less than or equal to 7, which is f of 7. And you have completed that already in trying to do the memoryless, trying to do this question. You have been working with that. So based on the formula we have, you can always get that in those formulas. Cumulative distribution of 7. This is greater than or equal to, here is less than or equal to, we should know how to adjust it. Even if you look at the memoryless function, if you wrote it neatly, you should be able to see that we computed the cumulative distribution function for the cumulative distribution. Then you are going to get that. And then it will be a probability. Maybe it is 0.3 or 0.25 or 0.63. What does the Chebyshev tell us? Within 2 standard deviations, there is at least 75% of values. So what you are expecting to get here is a number that is above 75%. Otherwise, it is not consistent with the Chebyshev inequality. Yeah, right? You still have to complete that too. Do you have geometric distribution there, Jacob? Do you have geometric distribution on that calculator? Yeah. So you can use cumulative. Whenever you have less than or equal to is the cumulative, geometric cumulative distribution. What do you get for probability? 0.96, that's 96%. So 96% of values are within 2 standard deviations from the mean. That is what it means. Is it consistent with the Chebyshev's inequality? Somebody should check again. I'm not sure he's right, but I just want you to check. I can check it simply like this. I say that P of x greater than or equal to A I will say greater than or equals to A is this. P of X less than A when A 1 minus P. P of X less than or equal to 7 is equal to P of X less than 8, which is 1 minus. I don't have calculators. You can use your calculator, but you can use this kind of manipulations. Does it work like this? 2 over 3 raised to the power 8 minus 1 subtracted from 1. You get the same thing. So we could be right. All these are we getting. I'm doing a mistake somewhere, right? I'm just saying it is not like because I'm doing it, it will be correct. But sometimes you just check with something. You get somewhere, you check your formula. The calculator can give it to you completely. Question? Pardon? This? 2 over 3? Like it was P equals to 1 over 3, so Q is 2 over 3. Number 8. Any other questions since we are on it? Number 9. I hope I have written enough for those who are on. So we just work on what we have done now is number 5. On number 5, number 5 is find the probability that mu minus 2 sigma is less than or equal to x less than or equal to mu plus 2 sigma. So compute mu and sigma. What was that? Maybe something on the computer. We are safe. So we are talking about number 9 now. Find the probability and according to the Chebyshev theorem, should be at least 75%. So what is number 9? If Z is a Poisson random variable with mean lambda equals to n, a natural number, show that P of Z equals to n equals to P of Z equals to n minus 1. That should not be hard. It's just equation. Have you tried? Somebody want to try? Okay. Sometimes there is something that is just missing. You should just do it. I don't trust myself too. You don't see sometimes how many mistakes I make. Okay, and then compare, right? Good. Mathematics is the same for everybody. Just make sure each step you are taking is correct. If you don't know how to move to the next step, just say, I don't know how to move to the next step. And that is why we come to class to ask questions. So sometimes you will need another person to help you. So you might just put yourself together and say, I'm thinking we can move this. Why? We said this thing in class, and that's how you are learning. You didn't see now, I didn't know what was the mean when you came to, where did you get, why are you doing 1 minus? But if you start telling me it's a geometric distribution, this is the formula, and gradually you will be building up your knowledge. Does it look like what you are doing, Maggie? So you use lambda equals to n and write the formula. Then still use lambda equals to n and write the formula for n minus 1. And then you will compare and see if it looks the same. Are those two numbers the same? That's the question. And we say that this one is n times n raised to power n minus 1, e to the minus n power n factorial. You are trying to do it in a very general way, which is, that's why it's applicable. Yeah. Notice that you do n and n plus 1. You did n and n plus 1. Look at the math. You did it with lambda. That's what you are not realizing. You did another problem that was a little more difficult. No, lambda equals to n. This one is more general because you are still having lambda. That's more difficult. It's good, but I didn't want to give you this because I felt like it's more difficult. It will count more, but I will not give more points, but normally it should count more. But do we see what I expected you to just look at? So your lambda is any number, any real number. So now, mine is n equals to lambda. Lambda equals to n, I have that. If I do this, you see here is n, this n, there is one n here. It will be n minus 1 factorial. That is what we come.
But we're writing in plus 1 that we can also work.
Yeah, it's just a change of n. Sometimes some people don't want to work with n minus 1 and n, they work with n and n. I'm sorry, n plus 1. Yeah, n plus 1 or n minus 1 n. So sometimes take the problem as, I'm not saying what you did is wrong, I'm just saying it in general. Now, whenever you have a problem, is it already time? Maybe we should be having 2 hours of probability. What about that, Maggie? Okay, 1 hour, 15 minutes twice. Maybe Tuesday, Thursday. But I like Monday, Wednesday, Friday. We go small pieces. Okay.